This is a circuit board for a flash from a regular disposable camera. This is the charge switch. This is the first transformer, consisting of a primary coil and a secondary coil, and also a feedback coil. This is the second transformer, consisting of a primary and a secondary coil. This is the transistor. This is the trigger switch, which is going to be used for a light switch. This is the main capacitor. Here is the trigger plate and flash tube. When the charge switch is connected, this completes the circuit through the feedback coil. Note that the current doesn't actually flow through the small capacitor, but draws the current. As positive charge builds up at one end of the capacitor, this buildup will turn on the transistor, causing the current to flow or to follow this pathway. Due to Lenz's law, a change in the primary coil causes a change in the secondary coil. This change sends a current through the diode towards the main capacitor. However, the change in the secondary coil also produces a change in the feedback coil. This change will draw away some of the charge from the small capacitor, causing the transistor to turn off, reverting back to the initial pathway. Note that the diode prevents the charge from the main capacitor from returning to the secondary coil. More charge is sent, increasing the voltage. This series will continue and the feedback coil will turn on the transistor, causing the pathway to go through the primary coil, affecting the secondary coil, sending more charge to the main capacitor, and affecting the feedback coil, and repeating again. This will continue until the charge switch is released. Here's the circuit in action. When the trigger switch is connected, this completes the circuit on the right side. A lot of charge has been stored up in the main capacitor, which now goes through the primary coil. As before, a change in the primary coil causes a change in the secondary coil. The secondary coil sends negative charges to the trigger plate. The negative charges building up in the trigger plate repel the electrons in the gas inside the flash tube. When enough dissociation of electrons occurs in the flash tube, the current will go through the tube. This excites the electrons, emitting light. All of this happens nearly instantaneously, resulting in the flash we see. When our BB gun was created, magnetic wire was wrapped around a quote-unquote cannon. This is intended to create an opposing magnetic field. As a current is passed through, the BB is not magnetic, but the changing magnetic field induces an opposing force on the BB, propelling it out of the cannon.